Again, as we finished up our discussion of the right triangle trigonometry relationships, and we're headed into a discussion of the unit circle relationships, I wanted to review two of the special right triangles that we often encounter throughout trigonometry and calculus. In a separate video, we've looked at a 45, 45, 90-degree triangle. And now I want us to focus on a 30, 60, 90 triangle. So we begin with what's called an equilateral triangle. And one of the things we know about an equilateral triangle is that all three sides are the same length, which also means all three angles are the same. So if the angles have to total 180 degrees, 180 divided by 3 would it mean that each angle is 60 degrees. And then if I draw what's called an altitude, if I drop a perpendicular line from the vertex of the triangle to the opposite side, that altitude breaks our triangle up into two smaller triangles. It also bisects that 60-degree angle so that you have a 30-degree angle and a 30-degree angle, and it bisects the other side. So if we represent this short leg on our triangle as x, and you could do that on either side, x, then what we have really is that whole side would be 2x, the way that we have it drawn. Okay, so that means the other side, the hypotenuse, if you will, the angle side opposite the right angle, is going to have a length of 2x. And it would be true on the other side as well. So I know that kind of the short leg of my triangle is x. I know that my hypotenuse is 2x, but I don't know the length of the altitude. I'm going to label this as A because it's our altitude. Okay, and we want to figure out that side. Well, since we have a right triangle, we can use Pythagorean Theorem. So if you focus on this triangle right here, highlighting it in yellow. Okay, this triangle. Then we can, again, develop a relationship between the three sides. So I'm going to focus on, use Pythagorean Theorem to figure out the value of A. So I have A squared, because that's one of my legs, plus x squared, the other leg, equals the hypotenuse squared. So I have A squared plus x squared equals 2x times 2x is 4x squared. I'm trying to solve for A, so I'm going to subtract x from either side to get the A by itself. So I have A squared equals 3x squared. I'm then going to undo the square by taking the square root. Again, I can ignore the negative because it's a length. So A equals x times the square root of 3. So my altitude has a length of x times the square root of 3. So then from that, we can develop, excuse me, a relationship of the sides. So x here represented the short leg. Okay, it's the short leg, or it's the leg opposite 30 degrees. And then we've seen that the other leg is x times the square root of 3. We'll call that the long leg, or the side opposite 60 degrees. And then your hypotenuse is 2 times the x. So again, we can develop that particular relationship between the legs. And then from that, we can begin to think about the measures of a 30-degree angle as well as a 60-degree angle. So you have 2 focal points here. So I'm going to come down a little bit. I'm going to kind of resketch our triangle that's highlighted in yellow above. Okay, so we have a 30-degree angle. We have a 60-degree angle. We know the short leg is x. The longer leg is x times the square root of 3, and the hypotenuse is 2x. So if we focus for a minute on the 30-degree angle, our focal point's the 30-degree angle, which makes the short leg opposite, the long leg is adjacent, and then of course you have your hypotenuse. So we can think about the cosine. Excuse me, we should start with sine. We usually start with sine, don't we? So let's start with sine. Okay. The sine of 30 degrees, which is the opposite over the hypotenuse, we would have x over 2x. And then if I simplify that, I would have an x in the numerator with a placeholder of 1, x in the denominator, they divide out, so we have 1/2. Okay, so the sine of 30 degrees is always going to be 1/2 regardless of the lengths of the triangle. Then let's think about cosine of 30 degrees, which is the adjacent over the hypotenuse. So we have x times the square root of 3 over 2x. And again, if I do my simplification there, I notice again I have an x in the numerator and an x in the denominator, which leaves me with square root 3 over 2. So the cosine of 30 degrees will always be the square root of 3 over 2, again, regardless of the length of the sides. And then let's think about the tangent of 30 degrees, which is the opposite over the adjacent. So we have x over x square root 3. So again, I notice that I have an x in the numerator and an x in the denominator with a placeholder of 1. So I have 1 over square root 3. Remember, we don't leave a square root in the denominator, so we're going to multiply the numerator by square root of 3 over square root of 3, which ultimately gives me square root 3 over 3. So the tangent of 30 degrees is square root 3 over 3. And again, that's always going to be true. It doesn't affect, the size of the triangle doesn't affect that trigonometric relationship. Okay, so let me draw the triangle again, but this time we want to focus on the 60-degree angle. Okay. So we have our right angle. Here's 60 degrees. Here's 30 degrees. We know the side opposite 30 is x. The side opposite 60 is x square root 3, and the hypotenuse is 2x. And our focal point this time is going to be the 60-degree angle. So if you think about it, now you have, this is the opposite side, this is the adjacent, And this is, of course, the hypotenuse. So if I think about it, I have the sine of 60 degrees is opposite over adjacent. Okay, so we would have x over the square root of 3 over, whoops, sorry, my mistake. It's not over opposite. It's over the hypotenuse. Sorry about that. So I have x over square root of 3 over 2x. Again, I notice that I have an x in the numerator and the denominator. They will divide out. Okay, so I have square root 3 over 2, which is the sine of 60 degrees. Then, if I think about the cosine of 60 degrees, which is adjacent over the hypotenuse, okay, I would have x over 2x. Again, simplifying that, I have an x in the numerator with a placeholder of 1 and an x in the denominator, so I end up with 1 over 2. So the cosine of 60 degrees is 1/2. And then finally, we could have the tangent of 60 degrees, which is opposite over adjacent this time. So I have x square root of 3 over x. Again, simplifying, I have an x in the numerator and an x in the denominator. You still have that placeholder of 1. So we have the square root of 3 over 1, which is simply square root of 3. And again, 30-degree angle and a 60-degree angle are very commonly used ones. So again, you may want to commit these particular relationships to memory as we move forward. Okay, so again, that's a quick review of a 30, 60, 90 triangle. If you can remember, if you go back up here and remember kind of these definitions or the relationships between the sides, that the x is your short leg, x square root 3 is your long leg, and your hypotenuse is 2x, you can always develop these using Pythagorean theorem and the right triangle trigonometric relationships.